Can you hear me now?
Perfect.
Perfect. And see me? Yes. Okay. So thank you very much for the very brief introduction and the help for the technical problems here, the small technical problems. And ladies and gentlemen, welcome back to the, as Katja said, the very last presentation in this room today. So there are 9 minutes left. I will do my best to keep you not longer than 3 hours more now. So you all know about the discussion on oil palm or palm oil, because oil palm plantations are growing on tropical forest land. And for this, the land is cleared and oil palms are planted, and not only in Europe, but also in North America. So in all countries where no oil palms are growing, they have a big debate on palm oil and oil palms. So during the Palmwood Net project, we have put a lot of emphasis on environmental aspects because of these very crucial political and debates. And I will share with you 3 aspects of our work very briefly. One aspect is the question of land use and biodiversity and substitution of tropical timber. This is one aspect. I did a little bit this morning already. And then the next is carbon issues and LCA studies we did. And the third part is the nutrient aspect with the export of OPT. We also export nutrients, and this needs maybe more fertilization later on. Okay, so if we look on environmental aspects, so this is a very big and very diffuse area because we have no official definition of aspects or of criteria. Even more, the question of indicators. What are the indicators for the environmental criteria is, and the relevance of the indicators is very much unclear. Therefore, everybody who is participating in the discussion defines his own view on environmental aspects. And on the left here, you have some of these views. They grow on forest land. This is bad. They destroy the biodiversity. This is bad. This is very much intensive agriculture. This we don't like. And we have sea emissions because this is a so short rotation crop compared to 100 years of tropical forest. So on the other hand, we have the arguments from the other side. We have products, oil, wood, and fibers, mainly oil, palm oil. Humans need this oil or these products, and plantation provide labor. And oil palm has a better productivity than any other oil crop. If you compare it with soya, it's 3 times or 4 times as much oil produced per hectare, and so on and so on. So there's a big debate anyhow, and there's no conclusion of the debate. So if we look on the land use and biodiversity, of course, oil palm plantation grow on land which has been covered with forests before, because all the tropical area, 100 years or more, have more or less covered with forests. And now we use this forest land partly for many uses, for infrastructure, for agriculture, and we use also the forest resources. And but we have to consider that most of these uses depend on the population and the people, and the number of people and their welfare. As more money they have, as more products they can buy, as more energy they consume. And so the problem with natural resources becomes bigger and bigger. Okay, so, sorry. So if we look on the forest cover development in tropical forests, so I'm talking on tropical forests. So the loss of forest cover in tropical forests between 1990 and 2020, 30 years, was, according to FAO, 420 million hectares. This is about 10% of the total area, tropical forest area. between 2015 and 2020, it was 10 million. So it was a bit less per year than before. So the FAO says that the agricultural sector is the main driver for converting tropical forests. First with cattle ranching, then the second is soya bean, and the third is oil palms. And these three together have 40% share of the loss of the tropical forest. So you can recalculate 40 multiplied with 420 is about 160, and oil palm is a third in this group. And then another 33% so is local subsistence agriculture. So the agriculture, this is not dealing with oil palms here. So the agriculture is really by far the number one. Nobody discusses so much about agricultural activities except soya, like with the oil palms. And if you look to the timber supply in Asia, I've talked before this morning, if we look at 2018 in comparison to 1990, so after almost 30 years, we see in Indonesia an increase of timber, but this is mainly due to the forest plantation. And we see a sharp decrease in Malaysia. So again, we have a problem in the wood supply, which was mentioned more often today. And so if we look to the very brief comparison of use of tropical timber and OPT. So if we look on the tropical forest and we harvest tropical forest, we produce quite a heavy damage to the forest and to the soil and to the biodiversity, because very often we have a selective cutting in the forest, and the damage to the remaining stand is quite big. So this is a carbon source. Then we use the wood, and we have very good quality timber, yes, and we can use it for very many products. And so this wood use has very limited negative or even positive aspects. So if you look to oil palms, if we harvest the oil palms, they are quite easy to harvest. We have no remaining palms because we make a complete cutting. We have very little or no damage to the soil, and we have little damage to the biodiversity. So this is a little bit difficult to discuss. So one can say, okay, the biodiversity is even lower than in a tropical forest. And if it is so, then the damage to the biodiversity is also quite low, is also lower. So the C aspect is even neutral or even positive. I mentioned this morning, if we leave all the oil palm trunks and all the biomaterial in the plantation, we have a lot of CO2 and even methane emission. So we have the simple harvest, we have the high volume per hectare, and we have a limited product range at the moment, but we have a very good and excellent CO2 balance. So I will talk to this later. So, and if we have a last look on the forest situation on the palm oil producing countries, maybe we look only to Malaysia at the moment, with a productive forest cover of almost 14 million hectares. We have close to 6 million hectares. The oil palm plantation, we have 16 million cubic meter of timber, industrial roundwood. We have a potential of at least today of 20 million oil palm trunks. And we have very little forest plantation. So the potential to supply wood from forest plantation in Malaysia is quite low compared to, for example, Thailand. They have started forest plantation much earlier because they had a complete harvesting ban on the natural forest. Also, Indonesia has quite a lot of plantations. So, and trends in forest plantation and agri plantations, you can see here, Acacia mangium is quite important. It's constant, Thailand, Malaysia, even declining Indonesia. Sengono albizia is produced in Indonesia quite a lot. This supplies Indonesia partly, teak in Thailand, and rubber wood is going down in Malaysia, it's going up in Indonesia, and oil palm is more or less constant in Malaysia and going up sharply in Indonesia. Okay, these are the potentials. So if we look on the CO2 aspects, and if we very briefly, really very briefly, compare three examples: a natural forest, a forest plantation, which produces, for example, Sengon, and the oil palm plantation. So these are the three types we can select: either natural forest or forest plantation or oil palm. And I make it very brief. If we harvest per hectare in one harvest operation, in the natural forest, we harvest about 20 cubic meters, in the forest plantation about 200 cubic meters, and in the oil palm about 150 cubic meters. We have a certain recovery, but what is important, we have residues, harvesting residues, which is 25 is 130. So if we look on the C effects of all these operations, then we have product storage. I don't go into the detailed numbers here. We have product storage, carbon in the product. We have material substitution, so we replace other materials. We have energy substitution. So this comes to these figures. And then we have to look what wood is extracted but not used, because this is an emission in the forest. Here we have a reduction in the C balance. Here we have an increase in the C balance. This is the balance from the residues here. And so the total C effect in tons C per hectare, or let's look on the tons CO2 per hectare here, for the natural forest is plus 27 tons CO2 per hectare. This means overall an emission of CO2. For the forest plantations, Sengon is 40, and for the Agri palm, for the oil palm is minus 14. So if we compare the different systems to produce wood, we even have an advantage for the oil palm trunks in that case. So if we look on life cycle assessment, we did a lot of work on life cycle assessment for the products. And so we had in the LCA, life cycle assessment methodology, we looked on it from Gretel, from the plantation to the mill gate for the ready-made products. We included the local electricity grid. Mainly we did this for Malaysia, and we looked on the residues used for fuel. We calculated, or we developed mass and energy balance, and we also looked on the impact assessment, so the standard procedure for LCA. And we evaluated 5 product types: lumber, different densities, dried and plant, the single layer boards, multi-layer boards like CLT, the block board, and the flash doors. All these products we have discussed today. And I give you just one example, the mass balance for a block board, 22 millimeters thick, with a core of low density OP, oil palm wood, and the faces with 2 millimeter local hardwood veneer. So the mass balance, we need 1.9 cubic meter of trunk. So we produce wet lumber, we have dry lumber, we have 0.7 cubic meter wet waste and 0.1 cubic meter dry waste. Then we have 1 cubic meter of dry lumber plus the veneer gives 1 cubic meter blockboard and again dry waste. So the energy balance for this 1 cubic meter of blockboard, we need 7 kilograms of diesel. In the plantation and in the mill, 103 kilowatt hours electricity and about 1,400 kilowatt hours of heat. And the heat is 100%, is mainly drying, is 100% supplied with the residues. And here you see the result for global warming potential in tons of CO2 per cubic meter of blockboard in that case. So the supply of the trunks. The drying is the biggest emission or the biggest negative effect in CO2. The production process itself is much lower. And if we detect the waste to energy, all the waste is converted into energy, then we get a total of roughly 80 kilograms of CO2 per cubic meter of blockboard. So it is at the final end, it is positive. And this is only the LCA, only the LCA for the production. There's nothing included like storage capacity, nothing for substitution, whether it's energy or materials. So even the production process of this type of product is carbon free. So if you look in my last example, deals with the nutrients balance. So of course we have the plantation and we get water nutrients from the soil. We also get nutrients through fertilization. So average figure is about 150 kilo nutrients per hectare and year, depending very much on the age of the plantation, very much on the soil conditions and so on. And if we use biomass, and we already use biomass a lot, the fruit bunches, so the oil and the empty fruit bunches is the biggest share of nutrient export. This is quite a lot. And if we look on the trunk utilization, we also export nutrients with the trunk. So this was a big issue in our research. So what we did is we took samples from a plantation near Kulai in southern Malaysia, with palms between 72 and 30 years old in June 2018, and we did a lot of lab testing in Hamburg. And so we looked on all the nutrients in the trunk and the nutrient distribution within the trunk. And I only show you the so-called main nutrients here, the 6 main in terms of quantity. So the percentage based on dry mass wood without bark. This is only the trunk here. So we have approximately 2.5% of the mass of a trunk are these nutrients. And we can recalculate it to kilograms per cubic meter of trunk. So we end up 8 kilograms of nutrients per cubic meter of trunk. And you see 50% is potassium, K potassium. This is the main nutrient for many crops, especially for oil palm. And so with this information, we did a calculation just to show how much nutrients we export and what is the relation to the whole nutrient cycle. So if we export, for example, 70 cubic meter per hectare, these are the first 5 or 6 meters from a trunk. So this 37% of the total trunk volume. So the total biomass on a hectare, the total biomass or everything, trunks and fronds and so on, is roughly 100 tons, dry tons per hectare. So these 100 dry tons contain 1,200 kilograms of nutrients. So this is the starting point in a plantation under conversion. So in the exported trunk biomass, we export the 70 cubic meters. This is 25 tons dry, multiplied with these 8.5 kilograms. So we have 324 kilograms in that calculation, kilogram nutrients exported with the 70 cubic meter of trunks. So these 6 nutrients. And then we process the trunks. So in the wood products, at the end of processing, we have about 8 to 10 tons of the material, the wood. So this 7 to 9% of all the nutrients here. In the wet residues, we have 10 tons, and dry residues we have 15 tons. So we have more residues than products. We know this. And so what we can do now theoretically or practically, is to return, for example, the wet residues and burn only the dry residues, and return also the ash from incineration. Or we burn everything, whether it's dry or wet, and return the ash, because in the ash we find almost 100% of these nutrients. So we return to approximately 220 kilograms of nutrients from the 320, and about 100 to 110 kilograms remain in the product. So of the 1,200 which are in the plantation at the time of clearing, finally we end up, under best case, returning of waste. In the best case, we end up with about 9% in the trunks, or 6% in the nutrients of the plantation biomass. So if we compare this with this amount of nutrients we export at the final end with the fertilization schemes over the 25 years, I could say this is almost nothing. So this is no argument that we shouldn't use oil palm trunks for products. This is absolutely no argument. So we, as I said before, about 150 kilograms are fertilized on average every year. So in 20 years' time, for example, then we fertilize 3 tons and we take out a handful of kilograms. So when I come to the conclusion, so we have the 3 areas. So I've mentioned that we use the oil palm plantations to produce the oil and produce other things, multifunctional. So we have a problem with biodiversity, yes, but we have to study more what is really the difference of tropical forest, the oil palm plantation, and other agricultural schemes, because we need to supply human beings. So the question is how we do that, and how is the influence on biodiversity from these different possibilities. So we have a very positive aspect in the carbon issues, and we have almost no effect in the nutrient export. And so we are quite positive at the final end from the environmental point of view, if we sum up everything under this term, environmental point of view. With that, I thank you for listening, and I'm happy to answer questions either now or later via telephone, WhatsApp, or even other means.
Thank you so much.
Thank you.
The last and good presentations bind up. So I think that if there is no question, then Dr. Khadja will summarize just that one, and then we can conclude that today's session. And
sorry, Professor Jawad, I didn't understand. Should I summarize the session or the last presentation?
Yeah, means it's not that long, just to 1 minute, 2 minutes, you know, just in this session.
Yeah.
It's so not to summarize all. Or if you want, I can summarize, you know.
Yeah, we had interesting, from my point of view, a very interesting session, because we were very deep in the products and the production of the products. If you look at the GLT and the grading for the GLT and the drying, which is necessary, and especially the drying defect, because this is, which we didn't discuss in the morning, but now in the second session today here in room A, is one big issue. If we look at the production process, one big issue is the drying concept or drying program, because we have the big issue how to avoid the collapse. Therefore, we had very interesting presentations, and we had one presentation with a much more experienced product, the plywood, and perhaps we can use the experience there for the newer products like blockboards or GLT and CLT. And we ended up with the, I think, very important point, the environmental aspects, because we've seen that it's not necessary that we leave the raw material on the plantation. It's better to take it out. This is what I learned. It's better to take it out of the plantation and bring the ash back, because then we bring back to the plantation every year some ash, or not one big amount of nutrients in 1 year, in the year where we harvest the plantation. So we learned that it makes sense to use the material from the environmental and ecological point of view. So we meet tomorrow morning, because we continue with a special session on the wood tomorrow morning.
Tomorrow this special session is going to continue.
Yeah. At the same time, I learned it's
same
at the
time.
afternoon in Malaysia, 3 p.m. in Malaysia, and 9 p.m. in Germany. I think this is the biggest distance we have at the moment in this session. So we have to calculate. I think UK is 7 in the morning, because they are 2 hours back. So we meet tomorrow morning in room A at 15 p.m. GMT +8. So everyone has to calculate when he or she has to get up this morning or this afternoon. For the Malaysian colleagues, have a good evening. For the German or European colleagues, have a nice afternoon.
Thank you so much, Dr. Katja. Thank you so much for sharing the chair. On behalf of organizing committee, I'm highly thankful to you for conducting the session chair of session A2. And then we look forward, all of you, for tomorrow with new energy and new powers. We are going to meet tomorrow again, and we will look forward more research on the OPT on tomorrow. Thank you so much.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.